Hello guys, I'm Afrasyab, your physics teacher. I hope you all are doing well. Today we have to learn about the density. What is meant by density? Until now we have learned about the topic 1 which is related with the physical quantities and measurement, topic 2 which is related with the motion, and topic 3 which is related with the mass and weight. Now we will learn about the density. In section 1.4, which is topic 4, here we will learn about what is meant by density and how you can measure the densities of different objects. What is meant by floating? There are some formulas that are used to calculate the density, and there are also some example questions. At the end of each section, there are some questions that you need to solve. First of all, what is meant by density? I can simply define it as the density is mass per unit volume of a substance. I write here density is equals to mass per unit volume of the substance. What is the mass of the substance, and divide this mass with the volume to get the density of that substance. The density is basically written with the symbol rho. And if I talk about the unit of the density, what is a unit for the measuring mass? Do you know about it? The mass is measured in kilogram, which is the SI unit, and the volume is measured in meter cube. So the unit for the measurement of the density comes to be kilogram per meter cube. The symbol for the density is rho. It is basically rho, and its unit is kilogram per meter cube. So here the definition of density is given. Density of a substance can be defined as mass per unit volume of that substance. Just divide mass with the volume to get the density of any object. Next, we see the relation of the density with the mass and volume. You know by this equation that density is equals to mass per unit volume. By this equation, I can write that density is directly proportional to mass and density is inversely proportional to its volume. By this equation, I can simply say that larger the mass of the substance, greater would be the density, because both of these are directly related with each other. By increasing one quantity, the other quantity also increase. So I can write here, when I increase the mass, the density also increase, but the density has inverse relation with the volume. It means that if one quantity increase, other has to decrease. So if the volume increase, then accordingly the density would decrease, because both of these are inversely related with each other. So I can simply say that the substance with larger mass has large density, but the substance with the smaller volume has large density. It's given here, the object with lower density have a lower mass. Lower density means lower mass because density is directly proportional to the mass. Similarly, objects of the same size made of high density material have a high mass. Same size means that the volume should be same. When the volume is same, high density means that higher mass. The same relation holds here, that density is directly proportional to the mass. For example, a bag full of feathers is much lighter than a similar bag full of sand. If you take two bags, in one bag put feathers and in the other bag put here sand. then you will observe that the density of the sand bag is much heavier as compared to the density of the bag which is full of feathers. It is because of the reason the sand is heavier as compared to the feathers. Here on the side you can see there is a triangular formula. I will explain it later once I explain the formula for the density. So here is a formula of density. Density is equals to mass per unit volume. And the symbol for the density is rho. The mass is represented by m and the volume is represented by v. So density is equals to m over v. From here if I talk about the unit, you know that mass is measured in kilogram and the volume is measured in meter cube. So the unit for the density is kilogram per meter cube, which is the SI unit for density. Now let's go back to the triangular formula. Here in this formula, first of all, I write here density is equals to mass per unit volume. If I have to calculate the mass, I need to make the mass as a subject. So I can simply write here mass is equals to, as you can see the density and volume both of these are appearing at the bottom. So just multiply both of these, density multiplied by volume. After that if I say that you want to calculate the density, then make the density as a subject. I can simply write here density is equals to, here the mass is appearing at the top. So there is mass and the volume is appearing at the bottom. Mass per unit volume. After that, if you want to calculate the volume, then you can easily calculate by the same formula by making the volume as a subject and mass is appearing at the top. There would be mass per unit density because density is appearing at the bottom. So I can simply say that you can rearrange this triangular formula when the values of the two quantities are given and you need to find out some unknown quantity. If I suppose that the value of the mass and volume is given and you have to find out the density, you just need to use this formula. If the value of the volume and density is given and you have to calculate the volume, you need to calculate the first formula. So in this case, you can simply rearrange this triangular formula to calculate the unknown quantity from here. Again, it's the formula of density which is mass per unit volume. Next, we talk about the densities of different states of matter. There are three states of matter, that is solid, liquid and gas. In all of these states of matter, the atoms are arranged in different manner. In the solids, the atoms of the solid are very close to each other. The spacing between these molecules is very small, such that you can see here, it's the structure for solid. But in the liquid, the molecules are not very closely to each other, but there is a very little bit spacing between the molecules. That's the molecule of liquid. And in the gases, the molecules can move freely. These molecules are very far apart from each other. There are large spacing between these molecules, so it's a structure for the gas. Now, depending upon the formula of the density, which is density is equals to mass per unit volume. See here in all of these figures, solid, liquid and gas, the volume is fixed. Like the space that they occupy is fixed. Now you have to see depending upon the mass. Where the particles are closer to each other, of course their mass would be large and density would be larger. It means that in the solid the molecules are closer to each other and there are large number of molecules in the given volume, so that the density would be large for the solid as compared to the liquid. Because in the liquid the molecules are arranged but there is a distance between these molecules. so that when the molecules are a distance apart from each other, the mass would be small and the density would be small as compared to the solid. But in the gases, as there are few molecules and these are very far apart from each other, so the density of the gas is very small as compared to the liquid and the solid. So basically it's given here, the solids are more denser than liquids, which are more denser than gases. I can simply say the density of solid is larger than the density of liquid, which is also larger than the density of gases. So you need to remember this order of the density for different states of matter. Why the density order looks like that? It is because of the reason, because for the same volume, the molecules of the solid are closely spaced as shown in a figure, because the molecules of the solid are very closer to each other, due to which the density of the solid is very larger as compared to the liquid or the gases. You can also see the second figure here. The molecules are also shown. Here is solid, it's liquid, and that is gas. So these three states of matter, in all of these, the solid is much denser as compared to the liquid and the gas. Here is the exam question that appeared in February-March 2021. A small bottle has a mass of 20 gram when empty. So there is a bottle whose mass is 20 gram when it is empty. The volume of the bottle is 10 cubic centimeter. When full of liquid, when bottle is filled with liquid, the total mass is 150 gram. This is basically the mass of the liquid plus bottle, because the total mass is given. What is the density of the liquid? You need to calculate the density of that liquid. Option A, 0.50 gram per cubic centimeter. B, 2.0 gram per cubic centimeter. C, 13 gram per cubic centimeter. D, 15 gram per cubic centimeter. So let's see answer and explanation for that. Here we just need to use the formula of the density, like density is equals to mass per unit volume. Volume is given, which is here 10 cubic centimeter. I write here volume is 10 cubic centimeter and the mass is not given. The mass of the bottle and the mass of bottle and liquid combined form is given, which is 150 gram, but the mass of the liquid is not given. It means that we need to find out the mass of the liquid. I can simply write here the mass of bottle plus liquid. The combined mass of both of these is equals to the sum of the separate masses. The mass of bottle plus mass of liquid. From here you can easily calculate the mass of liquid. It would be equals to the mass of the bottle and liquid is 150 gram. So here would be 150 minus the mass of the bottle, which is 20 gram. So you get 130 gram, which is the mass of liquid. So you need to use this value of the mass. The mass of the empty bottle is given, which is 20 gram. The mass of the bottle when it is filled with the liquid is 150 gram. Then the mass of liquid would be equals to the combined mass of the liquid plus bottle minus the mass of the bottle. Then you get 130 gram, which is the mass of the liquid. The volume of liquid is given, which is 10 cubic centimeter. Then you need to use the formula of the density, which is density is equals to mass per unit volume. Put here values. The mass is 130 gram and the volume is 10 cubic centimeter. You get the density which comes to be 13 gram per cubic centimeter. It means that answer C is correct. Let's see the answers again. Here 13 gram per cubic centimeter is given in option C. So C is correct answer here. Sometimes when you want to find out the density, you always know that you require mass and volume. The mass of the object is given, but its volume is not given. But depending upon the shape of the object, you can easily find out the volume. Here I consider the sphere and its radius is r. If I suppose that you are given, there is the sphere whose mass is 20 kilogram. What is its density if its radius is 0.2 meter? Then how you can calculate the density? For that, you simply need to know the formula that is used to find out the volume of the sphere. The volume of the sphere is equals to 4 over 3 pi r cube, where r is the radius. So put your value for the radius, you calculate the volume and then use this volume to find out the density by using density is equals to mass per unit volume. I can simply say that in sometimes in the questions, the value of the volume is not given directly, but they tell you about the shape of the body as well as some parameter, just like radius in the case of sphere. Then you can easily calculate the volume by using the formula of that shape. Then put this value of the volume in the formula of the density to find out the density. So it's given here. The volume of an object is not given all the times. It can be calculated by using a volume formula based on the shape of the object. Here I consider the sphere and this sphere has radius r. So the volume of the sphere is equals to 4 over 3 pi r cube, where r is radius, whose value you should be given in the question. So you have to use this formula for the calculation of the volume of sphere. If instead of sphere I consider that there is a cube, then how you can find out the volume of the cube? Again, as you know that the cube has all the sides of same length. If all the side has the same length, which is d, because one side here I consider it has the length d. So I can simply say that when you have to find out the volume of the cube, you just need to multiply the side length 3 times. D multiplied by d, multiply it with d to get d cube. So just multiply side length 3 times to find out the volume of the cube. So volume of the cube is given, which is equals to d cube, where d is the side length of cube. So instead of cube, if I consider that there is a cylinder and you have to find out the density of the cylinder, you don't know its volume, then how you can find out the volume of the cylinder? First of all, here you can see that r is the radius of that cylinder, while d is the length of the side. So you can simply use the formula of the volume of cylinder, which is pi r square multiplied by d, where r is the radius and d is the side length. Just use this formula to find out the volume of the cylinder. If I ask a question from you, if I suppose that there is a cylinder whose radius is 0.2 meter and its side length is given 6 meter. Then you need to find out the density for that cylinder if the mass of the cylinder is 20 kilogram. You need to solve this question and it's basically for your practice. Here is again our exam question that appeared in May-June 2019. The diagram shows the 4 solid blocks with their dimensions and masses. There are 4 solid blocks whose dimension and the masses are given. Which block has the greatest density? So here you have to show that which one of the following block has the largest density. You have to use the formula of the density, which is mass per unit volume. Here the volume is not given, just the dimensions is given. So I can simply say here, when you have to calculate the volume, you just need to multiply the area which is given here. Area multiplied the length of side. Multiply both of these to get the volume. Find out the volume for all of these 4 solid blocks and see that which one of the following has the largest density by calculating the density using the same formula mass per unit volume. Let's see the answer and explanation. Here you have to use the formulas. Volume is equals to area multiplied by length and density is equals to mass per unit volume. For the block A, the mass is given 14 gram and the volume is 10 multiplied by 2.0. How you can get this? Just multiply the area with length. Here area is given which is 10 centimeter square and the side length is 2.0 centimeter. You just multiply both of these to get the volume. So it's given here the volume comes to be 20 cubic centimeter. After that use the formula of the density which is mass per unit volume. Put here the values of the mass and volume. You get the density that comes to be 0.7 gram per cubic centimeter. See the unit for the density. The mass is given in gram while the volume is given in cubic centimeter. So you have to use the same unit for the density which is gram per cubic centimeter. For the block B, the mass is 48 gram and the volume is 20 times 2.0 which is area multiplied by length. You get 40 cubic centimeter volume. Then calculate the density by using the same formula mass per unit volume. You get 1.2 gram per cubic centimeter. It's the density for the second block B. Next, find out the density for the block C. The mass is 54 gram and the volume is obtained by multiplying the area with the length which is 10 times 2.0 which is equals to 20 cubic centimeter. Use that value of the mass and volume, you get the density that comes to be 2.7 gram per cubic centimeter. For the block D, the mass is given which is 68 gram and the volume you get 40 cubic centimeter. Use the formula of the density, you get the density comes to be 1.7 gram per cubic centimeter. At the end, you need to see the density for all of these blocks and you will observe that the density for the block C is larger as compared to A, B and D. You can also see for the block D, the density is 1.7 while for A, it's 0.7 and for B, it's 1.2. It means that the density for the block C is larger as compared to A, B and D. So C answer is correct from here.